In this lecture, we are going to learn about some problems based on construction of analytic function using Milne Thompson method. Consider this example. Construct analytic function f of z of which imaginary part of f of z v of x comma y equal to minus 2 sine x times e power y minus e power minus y. We all know that sine hyperbolic y equal to e power y minus e power minus y divided by 2. So, in this place, you can write 2 times of sine hyperbolic y. Therefore, this imaginary part, you can able to get it as minus 4 times of sine x into sine hyperbolic y. Now, you have to differentiate this v with respect to x partially. So, differentiating v with respect to x, here x term is sin x, differentiation of sin x will be cos x. Likewise, you have to differentiate v with respect to y. So y term you are having sin hyperbolic y. We understood that the differentiation of sin hyperbolic y, if you are doing the differentiation here, d by dy of sin hyperbolic y will give you e power y minus of minus will give you plus e power minus y divided by 2, which gives you cos hyperbolic y. So differentiation of sin hyperbolic y will give you cos hyperbolic y. Therefore, Vy is equal to minus 4 sin x cos hyperbolic y. Now, according to the Milne Thompson method, you have to take x equal to z, put x equal to z and y equal to 0. So wherever x comes, you have to put z, and wherever y comes, you have to put 0. We know that sin hyperbolic 0, here if you are putting 0, you will get e power 0 minus e power 0 divided by 2. So that gives you 1 minus 1 by 2. Therefore, this term vanishes. Now next, you are having cos hyperbolic y. Put y equal to 0. What you will get? E power 0 plus e power 0 divided by 2. So 1 plus 1 divided by 2 gives you 1. Therefore, put x equal to z. So Vy of z comma 0, we get minus 4 times of sin z. Now, we are going to substitute in the formula if the imaginary part of f of z is given. So, by making use of Milne Thompson method, Thompson method, we are getting f of z equal to integral of Vy of z comma 0 into dz plus I times Vx of z comma 0 into dz. Already we found that Vy of z comma 0, it is minus 4 sin z, and Vx of z comma 0, we found that it is equal to 0. So you are getting integral of minus 4 sin z into dz, plus you can take the integral constant c. So integration of sin z will give you minus cos z. Therefore, minus minus gets cancelled. You are having 4 cos z plus c. So f of z equal to 4 cos z plus c. Now, we are going to move on to the next example. Here, if you are seeing the problem, we are having slight changes in the imaginary part or real part. So, finding the analytic function f of z equal to u plus iv such that u plus v equal to x cube plus 3x square y minus 3xy square minus y square plus 4x plus 5, and we are having the condition f of 0 equal to 2 plus 3i. So what is the beauty of this problem? Here, if you are considering f of z equal to u plus iv, then here u is also coming, v is also coming. So we are not able to understand whether it is a real part of f of z or imaginary part of f of z. For doing or for identifying that term, we are going to consider f of z equal to u plus iv. Multiply f of z with I, you will get I times u minus I square is equal to minus 1, so minus v. Now, by adding these two, you will get f of z plus I times f of z equal to u plus iv plus iu minus v. Separate the real and imaginary part of f of z. You will get f of z equal to f of z times 1 plus I equal to u minus v plus I times u plus v. So you are taking this whole term as capital F of z and this u minus v is capital U and u plus v is capital V. So you can see this problem here. U plus v equal to they have given. Therefore, the given problem is given the problem is capital F of z, imaginary part of capital F of z. You have imaginary part of capital F of z. You are having imaginary part of capital F of z. Okay. So, here capital F of z equal to F of z times 1 plus I. Now, what is the procedure for finding the analytic function? You have to find out the first order derivative of capital Vx and first order derivative of capital V with respect to y. So, here V is given as this. Therefore, we are going to find Vx and Vy first before finding the value of f of z directly. So, first find what is dou V by dou x. Here you are having Vx is equal to, by differentiating here, we are having V equal to x cube, V equal to, let us write down here, V equal to x cube plus 3x square y minus 3xy square minus y square plus 4x plus 5. So now we are going to find out the derivative of v partially with respect to x. That gives you 3x square plus 6xy minus 3y square plus 4. Likewise, differentiating v partially with respect to y, you will get 3x square minus 6xy minus 2y. Okay. So put x equal to z and y equal to 0 in these two vx and vy. Therefore, you will get vx of z comma 0 equal to, so take x equal to z and y equal to 0. So x equal to z means 3z square. Then put y equal to 0, this term vanishes. Here this term also vanishes, so plus 4. Now in Vy, if you are putting x equal to z, you are having 3z square. Here y equal to 0, it gets vanished and this also get removed. Therefore, substituting in the formula, if the imaginary part of f of z is given, then you are having the formula as integral of Vy of z comma 0 into dz plus I times integral of Vx of this z comma 0 into dz. So, substitute it here. Therefore, integrating 3z square into dz plus I times integrating 3z square plus 4 with respect to z. So, you are having 3z cube by 3 plus I times 3z cube by 3 plus 4z plus you can consider the integral constant. Next, you can divide these two 3, okay, and then here also 3, you can divide it. Therefore, f of z equal to z cube plus I times 4 plus z cube plus integral constant. So, this capital f of z is, we know that it is 1 plus I into small f of z. Therefore, keep f of z alone. Here, and bring this 1 plus I to the right hand side. So it will go into the denominator. Therefore, z cube into 1 plus I divided by 1 plus I plus I times 4z divided by 1 plus I plus c by 1 plus I. So 1 plus I, 1 plus I from the first term gets cancelled, and you are having z cube plus I times 4z divided by 1 plus I plus c by 1 plus I. Now what we are going to do here is, we are going to remove I from the denominator of the second term. Therefore, multiplying by its conjugate, multiplying and dividing by conjugate, you will get 1 plus I into 1 minus I gives you 1. It is like x square minus y square, so I square. Therefore, 1 plus 1 gives you 2. So, you are having z cube plus I times 4z into 1 minus I divided by 2. Now, by multiplying I inside, you will get 4z into I plus 1 divided by 2 plus the constant term c by 1 plus I we can consider as c1. So, f of z equal to the required analytic function f of z, we are having it as z cube plus 2 times of z into 1 plus I plus c. Hope you understood.